Let's analyze a circuit using the node voltage method and take advantage of supernodes. That's coming up right now.
Hi, I'm Dr. Bob. There are no lectures here. I just solve problems, homework problems to help you understand how to do them. Electrical engineering, at your service.
This is Chapter 4, Problem 2, using nodes and supernodes. Calculate the V out in this circuit. And of course, now in this circuit, see if we can get there. Here's the V out right here. And let's see if I can't. Let's use a different color here. Here's a V out, and V out goes across these two nodes. Well, these two nodes right here. Yes. And of course, what we want to do is use nodes and supernodes. So it's counting the nodes. We have one node over here. This is node 2, node 3, and node 4. But we're going to use the essential nodes here. Those are most important. Now, essential nodes are the nodes that are 3 or more devices connected to it. So all 4 of these are essential nodes by definition. However, with using 4 essential nodes, that means we're going to have 3 equations. However, we'll notice here that there's a power supply across this resistor right here, which sort of makes this little branch over here kind of useless in determining anything, because really all it's going to have is 100 volts across this 30 ohm resistor, and that's it. That's going to be a fixed value. That's not really going to tell us anything. So, I mean, you're going to look at this, it's not going to tell us much of anything. The other thing is, these two nodes, or this is an essential node as well. Node 3 is also an essential node, and but it's got 2 resistors in parallel. Now that just is 2 devices, but that can be simplified to just 1 resistor, a parallel combination of these 2, over 45. The other thing is that this voltage right here, that's going to be a voltage that's fixed according to whatever this input over here is. So we have a plus and a minus over here. And that voltage is going to be V delta, which is this voltage over here, delta, or V delta coming in, divided by 5. And that's what this dependent voltage source does. So what's going to happen is the current through this is going to be fixed no matter what's on the other side of it. No matter what the voltage is, the current is going to be fixed according to what V out over these resistors right here are. So there's going to be some currents going this way and this way, no matter what we have. It's going to be dependent strictly on V out. So we can just use this as V out. And what we're looking at here is what we call, this would be this is going to be a supernode right here. So, and what that'll do is that'll connect these 2 right here in our equation and give us a single equation that we can use. So let's go ahead and write that equation. Well, let's see, make sure we understand what's going on. As I said, we're using lower node as the reference, which is this one, which means this is going to be referenced at 0 volts. We're also going to take advantage of the supernode. Let's see, as I said, node 1 is no information, node 2 is needed, node 3 is essential because there are 2 resistors in parallel. We can simplify that. Node 4, of course, is this bottom node, and we're going to use that. That's also essential, and we're going to use that as our reference. So we're really down to 2 essential nodes, which says this is what we're going to do. We'll have 2 essential nodes, and we're going to use 1 equation. So let's write that equation. We're going to look at all the voltage, all the currents going out of this node, this supernode, which are going to be that, and that. Alright, so what we have here is going to be, well, actually, before we do that, let's go down here and we're going to redraw this and put these 2 resistors into a single resistor. So we're going to call this R R45 will be our new resistor, is equal to 1 over R4 plus 1 over R5. And that is equal to, we have the numbers there, 1 over 30 plus 1 over 60. And then we're going to multiply this by 60 over 60 to get a nice number, and what we're going to end up with is 60 over, let's back up a little bit. And I can only back up so far. So we're going to multiply this by 60 over 60, and that's going to give us 60 divided by 60 over 30 plus 60 over 60. And that is going to be 60 over, that's just going to be 2 plus 1, which is going to be 60 over 3, and that's going to be 20 ohms. Alright, so that's our next, we're going to redraw the circuit. So here is the circuit redrawn right here. As you can see, we've got all the same things in here. This is our V1, this is our V, this is our V out. Here is our supernode. We can draw that one more time. So here's going to be our supernode right here. Now, so let's go ahead and write that equation. Now, so I'm going to work out the currents leaving the supernode, which are going to be, the first one here is going to be V1 minus V divided by this resistor right here, R1, and plus V1 minus 0 divided by R3 plus this is going to be V out. Now you might say we're going to look at V1 minus something, but really what's going to happen is this is going to be V out divided by R45. And all these equal to 0. Alright, so let's put some numbers in here. We know what V is. V1 minus 100 divided by R1, which is 12.5, plus V1 over R3, which is 25, plus V out divided by 20. All that adds up to 0. Now we're going to write a couple of relations here because we can't solve this. We have one equation but two unknowns, so we're still going to have to say what V out is going to be. Well, so V out is basically going to be V out is basically going to be V1 minus V delta divided by 5, which is this, and see this is going from positive to negative, so we're going to be losing, we're going to be dropping voltage. So whatever this dependent voltage source is V delta divided by the value of 5. Well, V delta is the value across this resistor. So now we can simplify that a little bit better. V delta, we still don't know what that is, but we're going to just call that, well, that's just going to be V minus V1, right? Alright, since this is positive, you see this dependent voltage source, this is positive, this is negative, and so this is going to be V minus the value at V1. And that's going to be the V delta. So let's drop those numbers in here real quick. I'm going to drop, let's put this into that, and then this into that. Alright, so before we do that though, I'm going to multiply everything over here times 100 because I've got some fractions in here. This is a 20, a 25, a 12.5. That's going to end up, that's going to clear everything out for me. So 100 divided by 12.5 is going to be 8V1 minus 800 plus 4 times V1 plus, it's going to be 5 times V out equals to 0. So I multiplied this whole equation by 100 just to clear it up. It's a little bit of algebra here. Now let's substitute these numbers in. 8V1 minus 800 plus 4 times V1 plus 5 times V out, which is V1 minus V delta over 5 equal to 0. Now we're going to drop something in for V delta over here. Rewrite this equation. 8V1 minus 800 plus 4V1 plus 5 times V1 minus, remember what this is, V minus V1, V minus V1 divided by 5. That's equal to 0. It's a 5 there. Okay, so this kind of comes out kind of neat. Read that, just a little bit of algebra here. Minus 800 plus 4V1 plus 5V1 minus V minus plus V1 equals to 0. You see this, the 5's canceled out over here and gives us a nice clean number. Now we have, I just have one number over here. Everything is, well, V, alright, V is 100. Alright, so that's 100. So that's minus 900. So I'm going to add all the numbers over on this side. What we have is minus 800 minus 100, and I'm going to put that over on the right side of the equation. So that's going to come out to 900, plus 900 on the right side of this equation. On the left side, I'm going to factor out the V1 from all these numbers and just add all these V1s up. Like 8 plus 4 plus 5 plus 1 equals to that, and this adds up to 8 plus 9 plus 1, which is 18. So we have 18 V1 equals to 900, and that gives us V1 equals to 50 volts. Alright, now we still don't have our solution because our solution is solve for V out. We don't know what V out is, right? So the next thing is to substitute this back into this number right here. Of course, we have to get V delta first. So let's get all these numbers real quick. Okay, so the first thing we're going to go after, this one of our first finds. Alright, it's not the solution, but it's a first find. V out is just equal to V1 minus V minus V1 divided by 5. So we came up with that equation when we put the V out together with V delta, which is what this is V delta over 5. Alright, so let's put some numbers in here. V1 we figured out is 50 volts minus V, which is 100 volts, minus 50 volts, which is equal to 50 volts minus 10 volts. And that gives us our solution. V out is equal to 50 minus 10, which is 40 volts. And that is our solution.
Thanks for watching my program. If you like my videos, be sure and subscribe to my YouTube channel. And for an organized listing of my YouTube videos, go to my website, www.wherearemyplacebos.com, and click on videos. Have a great day.